Всем привет! И это третий поток конференции Snow One, и с вами ведущий Тагир Валиев. Я сейчас нахожусь в Новосибирске, и у меня примерно 16 часов 27 минут, а это значит, что уже буквально через несколько минут у нас начнутся доклады. Я не знаю, откуда вы все, наверное, много людей из Новосибирска, но есть кто-то из других городов. Если что, у нас тут морозец, минус 20, надеюсь, у вас потеплее. Но так или иначе, я сижу в тепле, и у меня все хорошо. Если здесь станет холодно, у меня есть шапка. Сегодня на нашем треке 4 доклада, 2 из них на английском. Это будут первые доклады от Андреса и от Авио. И когда вы немножко подустанете от английского, вам будет полегче. 2 следующих доклада будут на русском от Виктора Гамова и Ивана Пономарева. Андрес нам расскажет про Maven, от Авио про NoSQL. Виктор Гамов нам будет рассказывать про Kafka, Confluent и другие интересные вещи. А Иван Пономарев даже не расскажет, а покажет, как выглядят изнутри структуры данных в Java. Каждый доклад будет занимать 1 час времени, после чего получасовой перерыв. И в течение перерыва вы можете либо послушать партнерские мини-доклады, либо пообщаться со спикером в дискуссионной зоне, ну или, например, сходить перекусить. У нас 4 доклада по часу – это 4 часа, 3 перерыва между ними по полчаса – это 5,5 часов. То есть мы заканчиваем в 22:00 по новосибирскому времени, и все эти 5,5 часов я буду здесь с вами в эфире. Не забывайте, что у нас есть телеграмный чат, как общий для конференции, так и специальный чат для 3-го потока. Не стесняйтесь в этом чате задавать вопросы по докладу, который идет в данный момент. После доклада, если останется время, вопросы из чата я буду озвучивать в эфире, и вы вполне можете их получить. Ну, в смысле, ответы на них получить. Так, ну, по-моему, это все, о чем я вас хотел предупредить. Давайте, погнали. Наш первый спикер сегодня – это Андрес Almiray из компании Oracle. Андрес – разработчик на Java и Groovy. Он имеет звание Java чемпион. У него более 20 лет опыта программирования и опыта проектирования. Я думаю, не каждый из вас может похвастаться таким опытом. Он участвовал в разработке веб-приложений и настольных приложений с самых первых дней развития Java. Андрес искренне верит в открытый исходный код. Он участвовал в популярных проектах, таких как Groovy, Griffon, JMeta и DBUnit, а также в создании собственных проектов JSON-Lib, EasyMorph, Graphics Builder, Jite Builder. Он один из сооснователей и нынешний руководитель проекта фреймворка Griffon. Итак, встречайте. Hello, Andres. How are you?
Hello,
Where are you from right now?
How are you? Well, thank you very much for having me and for inviting me to this great conference.
Great. Where are you right now?
I am located in Switzerland, and I live in a small town right in the corner of Switzerland, Germany, and France.
That's great. Is it cold right now there?
It was cold. We actually had snow like 10 days ago, but right now outside is beautiful. Spring is very sunny. The weather is going crazy around here in this area.
Wow, lucky you. So you are going to talk about Maven. And when you encountered Maven for the first time?
I think it was back in 2003, 2004, where Maven 1 was still out there. This was right before Maven 2 came out. So it is quite been a long time since I've been using this build tool.
Oh, I see. And how was your first impression of Maven?
Well, given that I was used to Ant at the time, and Maven gave us conventions, so it's actually a little bit of what I'm going to talk about in the session, but that's fine. It was quite refreshing to what the previous build tools that we have to use.
Okay, let's not spoil your talk. And the last and the most provocative question, Maven or Gradle?
It all depends, and that's another reason why I decided to do this talk, because people that know me know that I've been promoting Gradle for close to 12 years. So me talking about Maven now is like, what's going on? But didn't you used to talk about Gradle? So there are reasons to use one or the other. It's not. I cannot really say that you should always use one over the other. Again, it depends on your situation. And hopefully, what I'm going to show today will give you more information on when you can make that decision in a better way.
That's a great answer. Okay, it's time for the talk. Please, Andres, let's start.
All right, thank you very much, Tagi. So, everybody, welcome. And so, as you can see on the title, the talk of today is about Maven. And based on what we just discussed with Takir, yes, we are now aware of Gradle as well. I know there are people that prefer one build tool over the other. I was one of those that preferred Gradle over Maven for many years. And then I decided to have another look at Maven. So, well, you already know my name. I work for Oracle, and I say that I'm actually a seasoned sorcerer until my actual title is Senior Principal Product Manager. What we do is, well, I work in the database group, and we talk about many of the products and projects that are related to the database. And some of them happen to be in the open source space, and that's the reason why I decided to join and why I need to talk. I like to talk about these things because we do open source from the inside and from the outside as well. I love to talk about source. I love to talk about projects. It's kind of my passion. But anyway, enough of that. So let's get into the topic. So as you know, Java is now, well, this year it will be 26-year-old in May 23rd, if I'm not mistaken. And in the beginning, Java was created with a syntax very close to the C and C++ languages, because those were the dominant languages at the time. We're talking about 94 and 95. Okay, so that was a conscious decision to make it so close to C and C++ so that the vast majority of developers were able to jump from one language to the other. And the tools at the time were following exactly the same thing that we had in the past. So in order to build Java projects, you will use Make. Now, Make, even though it's kind of portable within different platforms, is not actually so much for Java that we're supposed to just write once, run anywhere. That's the advantage of using the bytecode in the VM. So when open source projects started to grow in the Java space, there was the need of an actual build tool that was native to the Java platform. And the first one to emerge was Apache. Given the timings that we are located, again, XML happens to be the most obvious choice for writing declarative builds, and XML was the choice for Apache Ant. The advantage of Ant is like in Maven, like in Make, where you can define anything you want to. You define dependencies within one task and the other, and that's how you structure your build. And that flexibility was also a little bit of its downfall because, well, every build was custom. Every build has its own structure and its own life cycle. So jumping from one project to the other was a little bit of a mess. And if the project structure was much, much bigger, then it wasn't really that scalable. So the developers that were maintaining Tomcat decided to have another look. And again, inside the Apache Foundation, another group of developers decided to create Maven. So we're talking now, this is around 2003, 2004, when the first version of Maven came out. And it was good. It gave us conventions. It gave us dependency resolution. It gave us a structure. So that allowed us to build even more complex projects. Although, after a while, there were some developers that were not really happy to be writing build files in XML. That was one of the first complaints, that XML is too verbose. And the other one is that even though we now have a project object module, that we have some sort of a structure for our builds, they were too strict. They were too rigid. So this band of developers decided to, again, come together and create another build tool called Gradle. And this is late 2007, early 2008. And this is about the time when I personally switch from using Maven to Gradle. I was a very early adopter of Gradle. One of the reasons I decided to switch is because I'm a member of the Groovy development team, and Gradle used Groovy as a DSL. I didn't want to deal with XML, and then boom, off I go. Now, Gradle gave us some of the capabilities that Ant had in the past, so you can create your own custom lifecycle, but it had learned from the past lessons from Ant and Maven, so it gave us more stuff. So that was me for 10 years using this tool. But I longed for some of the features that I remember using from Maven. So in an effort to see where I could take the Gradle into an area that was more into convention similar to Maven, I had a hard look at Maven. And the talk that we have today is a realization of those features that I didn't know existed in Maven. Reason being, Maven 3 came out 2 years later after Gradle. This we're talking about 2010. So I completely missed the boat. I didn't see anything of the new features on Maven because I thought, like many, that it's a simple build tool that has an XML DSL, so there's nothing interesting about it. It's so simple that it's not worth spending so much time in it. Well, I was very, very surprised. So this is a result of what I found, and it's just the tip of the iceberg. There are actually more features that I keep finding in Maven that make me think, well, maybe there are moments where it's better to stick with Maven if you're already using it, and there are moments where you will stick with Gradle if you're already using it. So let's start with something simple, and I will expect that some of these features you are already aware of, and then hopefully there will be some of these features that you will say, aha, I didn't know that you could do that. So let's begin with overriding project properties. Now, you can define properties for a project basically in 3 ways. You can put them in a properties block inside any of your POM files. You can have them exposed by plugins or modules in this case. So there are the fields that belong to a particular module. And you can also define them on the command line. Now, the thing that I didn't know is that, well, you can pass these parameters, these arguments, these properties on the command line and override what is already defined in the POM file or provided by the plugin. Another nice bit is that if you are a plugin author, the moment that you define a parameter for your module or your plugin for short, then those parameters are automatically exposed as properties that can be overridden by the developer that consumes your project. And that's quite nice. There's nothing extra that as a plugin author you need to do. It's just that it just happens. It's part of the conventions. So let me show you a little bit of what I mean by this. So let's go into the demo, and then we see some black terminal here. I'm going to change into a project. Right. So I'm going to show you a POM file that looks like this. This particular POM file says this is nothing special. It just have the gap properties, so group ID, active ID, version coordinates for my project, and one dependency. And if I'm not mistaken, this particular project has a main class, and that main class looks like this. It only prints out hello world. Now, if you notice again, if we look back into the POM file, there is no indication that I can run this main class. There's nothing. I can compile it for sure, right? Well, we'll see that in a moment. So the first thing that I want to show is if I run Maven version, this will tell me that I'm using the latest version of Maven. I installed it using SDK-man, and I have JDK 1.8 for this setup. Okay, so what happens when I run my program? So let's say I'm going to compile. So Maven compile, right? And this invokes Maven and compiles my classes. Everything is fine. Now, the next thing that I want to do, remember that I'm using Java 8 to compile. So Java P target classes and my class. And what I'm interested in is just the major version of Java. And for this, I have to say Java P minus V minus S. There we go. So when I decompile my class and look at the major version of Java, we will see which version of Java was used in the bytecode, right? And that happens to be major version 49. Now, if you remember the numbers, 49 matches Java 5. It's not Java 8. So what's going on? So the defaults for Maven is that right now they go all the way back to Java 5. So if you need a specific version of bytecode, you need to define it in the POM file. How can we make this happen? Well, we look back again into the POM file. We could define the block for the Maven compiler plugin, which is a bunch of XML. Or if we look at the documentation of the plugin, there is a set of dependencies, the properties that we can define to override those. And we can set it in the properties block if we want it. But if I want to just try something right now, I can define it directly on the command line. So if I go back to compile, and now I'm going to do a clean, so we actually do a full recompile, and I set the property from the documentation, which happens to be Maven compiler target, and I set it to 1.8. Right, so I recompile my whole project, and when I do the decompilation of my class file again and grep for the major number, it now is version 52, which matches Java 8. And this is what we expect. So any other property, any other field exposed by the plugin can be overridden on the command line just like that. Now, this is an important bit. So everything that is defined as a field or a property in the module can be override from the command line as well. Okay, so let's go back to the slides. The next one, and this is a pretty cool one, which I didn't realize what I was doing this because, well, it just so happened, is that you can invoke any plugin on a build without having to configure the plugin in the POM file. So there are many plugins that can be used as is, or there are other, these plugins can also be added into a POM file. So say, for example, that you would like to invoke the Echo plugin for a project. Well, you can add it to the POM file, of course, or you can set the gap coordinates on the command line, so group ID, artifact ID, and version. If you happen to omit the version, the Maven will download the latest published version for that particular GA coordinates. And then you supply the goal, in this case is the Echo goal, it could be any other goal for any other plugin, and pass in any additional parameters that the plugin may accept. So this is why it's a good thing that we can override plugin parameters in the command line, because if we were not to pass a value for the Echo message property, then the invocation of the Echo goal will do pretty much nothing, or might probably fail because it doesn't have the required arguments. Okay, so now let's go back here, and I'm going to show you a command that looks like this. So this is exactly what I had in the slides. So we see the invocation of Maven with the gap coordinates for the Echo plugin. The latest version is 1220. So I could avoid this, or so I pull in the latest, or pull in explicit version, then the Echo goal, and then pass a property like this. So this is what we're going to do. I'm going to execute that command, and notice what happens. There is invocation of Maven, and Maven downloads the Echo plugin, which I didn't have on my local repository. That's a good thing. So then it actually invokes the Echo goal for that plugin. Perfect. And here we got it. Hello world from Echo plugin. So notice what happens when I invoke this command again. Goes the invocation of Maven, and I got the output. Maven did not have to download the Echo Maven plugin and its metadata because it's already available on my Maven local. So that's pretty much it. That's quite neat. Now, remember that I said that that this application that I have right now can be launched. It's a runnable application, but I didn't configure a way to make it run. So what if I were to use a plugin to run the application? Yes, I can put it in my POM file, but if I want to just test out a theory, I can also just do it in the command line. So I got this other command right here that looks like this. We're going to compile the class and then invoke the exec Maven plugin with the full gap coordinates, the Java goal, and we pass an additional parameter, which is exec main class. If we don't define this parameter, then the execution of the plugin will fail because it doesn't have the required arguments. Okay, so let's do that. So let's invoke command number 1, and let's see what happens. Remember that the printout should be something like hello world, and that's exactly what we see here. Pretty neat, isn't it? Now, the fact that we can invoke any plugin like this is quite good, but it can be a bit tiresome to type the group ID and the full Maven plugin ID and whatnot. It so happens there is a set of plugins belonging to two different to the group IDs, the or Apache Maven plugins and or Powerhouse module group IDs. If this is the case, we can use the short notation. Have another command like this that looks like Maven compile exec Java. So that's the difference. Given that exec happens to be one of those blessed group IDs, I can use the short notation and then I cannot pass the different arguments. So if I were to invoke the command like so, we should see a similar result as we saw before. Let's see. Yeah, it didn't need to compile anything because the project was pretty much done and it just do the execution. And that's what it is. Now, if it's possible for you to define if you want a set of plugins that belong to a completely different group ID to also work in this way, you have to configure in your settings file. But of course, it's not portable from site to site because it belongs to your settings file. You have to also set that configuration in any other machine where you want to use the show notation. But I mean, that's not much of a problem. That's the reason why settings XML exists. But it's just so you know that you have to be very explicit where you want to use this particular feature. Okay, next up, this is one of the best things that ever came out from Maven and is also a source of constant headaches: dependency resolution. Dependency resolution in Maven it's not so complicated per se, but for some reason the rules are not really well understood. Now, they are the way that we define dependencies. There is a dependencies block where you define everything that your project might need in order to compile, to run, and to test. There are two types of dependencies: the ones that you define explicitly on your POM file as known as direct dependencies, and those dependencies that happen to be on a second, on a third, on an n level that are coming from your direct dependencies are known as transitive dependencies. Say, for example, you depend on foo, and foo has a dependency on bar. So from your point of view, foo is a direct dependency, and bar happens to be a transitive dependency. And the rules for resolving direct and transitive dependencies are a little bit different. So if you have a direct dependency, this is how it goes. When you resolve that, say, dependency, Maven will go through the hierarchy of your parents, in case that you have them, all the way to the super parent POM that is always there. And then collapses all the dependencies. And those direct dependencies that are closer to you, so that's your current POM, will be the chosen one. So if I happen to have dependency foo on my POM file, and the same dependency foo on a parent, but with different versions, then the one in my POM file is going to win because that is the one that is closer to me. If in the other case, for transitive dependencies, it also looks of the whole graph in your parent hierarchy, and the closest that is, and the first and the closest that is found in the graph is the one that is going to win. So if you had a dependency, say, I don't know which version 1 of the full dependency as a transitive one, and from your point of view, it takes like 3 or 4 hops to get to there. But from your parent point of view, it takes just 1 hop and the version is different, then the one from your parent is going to be chosen and not the one that is you have defined. And that's a little bit of a problem. We will see that. So last year, I ran a quiz on how to do dependency resolution in Maven, and I had 14 different questions. They're separated in 3 sections. One where you have just a simple POM file, the second section where you have a parent POM file as well, and the third section when you also have a BOM file as some sort of dependency. And as it turns out, the answers were all over the place. And I'm going to show just 2 questions, and you can look at the quizzes that later if you want to. So the first question was quite an interesting one. Say you have a POM file like this, where you have duplicate dependencies. You have duplicate versions of the same dependency. Guava. I mean, I chose Guava because everybody picks on Guava because most people hate and love Guava. It's easy to pick on this one, but what I'm going to show is not specific to Guava, it's specific to Maven. Okay, so if you have a POM file like this, I ask the question, what's going to happen if I tend to resolve dependencies? Is it going to be the first dependency, version 27? Or is it going to be version 28 because that's the last dependency? Or this is going to be a build error because you should not have duplicate dependencies in your POM file. Okay, so give you a second to think about this one and pick your option. And then what happens when I resolve dependencies for this thing? Now, by the way, how do you resolve dependencies? You can invoke the dependency plugin and the tree goal. Notice that I didn't use the full GAF coordinates. So this is a way for you to execute any plugin on your build file. This is the thing that I didn't know that I was doing because it's so common to resolve dependencies in Maven using dependency tree. But the fact is that you did not configure the dependency plugin in your POM file. Of course, I didn't, and it's not found on any of my parents. So this is invoking a plugin on the fly on your build. What this thing is telling me is that actually there is a warning. There is a duplicate dependency. We can see right there, we have two different versions. But maybe say, this is a malformed POM. Okay, but I will allow it because I'm going to allow it given that I'm going to select one version. It's probably not the one that you're thinking is going to be. Version 28 is the chosen one because that was the last direct dependency closest to me. This is not a build error. Actually, the build works. 35% of the people that answered this question chose the build error. So here's another question. Now we're going into the realm of transitive dependencies. Both Google Juice and Google Truth have a dependency on Guava. From my point of view, that's a transitive dependency. And Guava is one hop away from my point of view. So they are in the same location in the graph. But it so happens that Juice, that particular version, depends on Guava 25, and True depends on Guava version 27. So I ask the same question. If I resolve dependencies, which version of Guava is going to be selected? Is it going to be the first one? Is it going to be the last one? Or is it going to be a build error? Now, based on what we saw before, we might be thinking, so Maven chose the last version, 28. It was not a build error, all right? So now it's probably that this might not be a build error. And it may be the case that it chooses version 27 because it is the last version, right? That's what we saw before, okay? Let's do a dependency resolution here and notice what happens. The chosen version of Guava is version 25, the first transitive version, not the last. And that's the key difference between direct and transitive dependencies. So let's look at that. I'm going to change into another project. Let me show you the POM file. And this is kind of what we have in the slides. So I got Juice first and Truth second. So these are my transitive dependencies. And if I do a dependency tree here, like that, then the chosen version will be the one that is brought by Juice. That is version 25. What happens if we invert the direct dependencies? So let's go into transitive dependency number 2. And let's choose the POM like this. So now Truth is first, Juice is second. Invoke the command again, dependency tree. Look, so what happens. Chosen version now is going to be version 27. So it's not consistent regardless of what I say. If I want a very explicit version of Guava, I am in trouble. Is there a way to solve this problem? Kind of, and we will get back into that in just a moment. So when I was writing this particular quiz, and I of course went on Twitter and asked what's going on, and went into the mailing list. So what's going on about this? So Robert Schulte, which is the current Apache Maven PNC chair, so he's the leader of the Apache Maven project for the time now. He answered this. So from the early days, Maven was designed to look at the position of a dependency in the graph, not at the version. So we as developers, we are aware of what semantic versioning, and we have some sort of arrangements for resolving conflicts within versions. It just so happens that Maven doesn't use those particular conventions. It may be the case because semantic version is much recent than Maven. And he does pose the question, so what if maybe it's time to review this strategy and change it? So I think this is something that may be coming in late Maven 4. If it's not, it's going to be ready for Maven 5. You might be able to change the strategy for the dependency resolution. Right now, you cannot hook in a custom strategy, but there are ways to solve these things. How can we solve this? One of the ways that we can do it is by defining the dependency management block. So dependency management is kind of like a lookup table. You give it a set of coordinates, group ID, artifact ID, and version. And so whenever Maven tries to resolve a dependency, if there is a match for the group ID and artifact ID, then the version that is defined right there is going to be the chosen one. So what is going to happen with this particular example now is that even though truth and use they have versions 25 and 27 in Guava, the chosen version is going to be version 28. And I'm going to showcase it right here, which I have another version of this POM file that I can show you. So now I have chosen version 29 on Guava. Notice I have true and use defined. If the dependency management block did not exist here, the chosen version will be the one coming from truth, which is Guava 27, if I'm not mistaken. All right. Let's do a resolution here, dependency tree. And notice that the version chosen for Guava is version 29, what we define in the dependency management block. This is what we want to happen. Because if I were to embed the dependencies, direct dependencies, truth and use, I will still get version 29 as the chosen one. So now there is no conflict. There is no confusion. The resolution is quite deterministic. If there is a match, I'm going to give you that particular version. Okay. Another thing that we can do is configure the Maven Enforcer plugin, which I love this particular title, the Loving Iron Fist of Maven. At first, when I saw that, I was like, come on, that's a silly joke. But it's a very useful plugin because more often than not, the moment that you configure this plugin on your build is going to break. And that is a good thing. That means there is something that is not configured correctly and that we were not aware of. I did a very unscientific poll on who uses the Maven Enforcer plugin right about the time where I did this particular questionnaire. And it so happens that it's quite sad that not that many people use the Enforcer plugin. And even there is a larger proportion of respondents that said, I have no clue what this plugin is doing. Well, we need to change that. Okay. If you were curious to know about the different questions on the quiz, well, the green portions are those that got most of the questions correctly. We got more than 500 people answering the questions, and only 7 out of 509 got all questions correct. I didn't even get those questions correct. I think I got like 12 or even 11 questions correct. These are how the different sections look like. So one is a simple POM, the other is with a parent POM, and the other is the answers with a POM file. And we can see clearly that most people understand when working with a simple POM. That's okay. We get a little bit in trouble when when working with parents. And when it comes with BOM files, it's like, oh, okay, no, we give up, right? So there's a link there at the top for the quiz and the different questions and the analysis on the different questions in case you're interested. Now, this particular quiz uncovers some of these misconceptions or missing concepts that we have about dependency resolution. And if you ever find yourself into dependency resolution or class path hell, well, there is an answer for you. So there is this great session, great talk by Ray Senk and Robert Schulte about the dependency resolution with Maven, and they show in this talk different options and different strategies to solve some of the problems that you encounter. Now, the link there is a link to the slides, and there's a link to the video that they did back in the JFAL 2019. And it's a really good session. I highly recommend you that you have a look at if you ever had any troubles resolving dependencies with Maven. Okay, changing the pace. You might have seen a few funny memes running around on the interwebs regarding Maven clean install. Now, this is kind of like a crusade that I have on my own, which is point out that most times you don't have to do clean, and definitely you don't have to do install just because you want to build a project. And I'm going to showcase this in just a moment. So sadly, or actually funnily enough, the first rule of Maven Club is you do not do Maven clean install. As you know, the second rule of Maven Club is you definitely do not invoke Maven clean install. The third rule of Maven Club is you go for Maven Verify instead. And if this is to a gritty reference, well, why don't we put rainbows on it? So what is going on? What is Maven Verify? Verify is just another lifecycle phase that Maven has. Maven is an execution engine that has a series of life cycles. There's a default set of lifecycle phases, and for each phase, the plugins will hook into or bind to and provide goals. So that's exactly how it goes. Maven goes from one end of the lifecycle to the other one, and for each lifecycle invokes all the matching goals. It's as simple as that. Now, Verify happens to be the lifecycle phase that is right before install, okay, and right after package. When you're building a multi-project build, this Verify makes more sense when you're in a multi-project build, but of course you can invoke it in a single phase, a single project, is that when you're building everything on a multi-project build, you have something that is called the reactor. Okay, and for every project inside the reactor, the goals that you invoke are going to invoke for each one of them in order. And if I invoke install on my reactor, well, every single artifact produced by that particular module is going to be pushed to a local repository. That's what install is supposed to do. Copy files from one location to the other. And those files are created by the previous life cycles, like package. But because Verify is right before install and after package, it's just enough to call Verify or even package if you want to. Verify will also invoke integration test cases in case that you have them using the failsafe plugin. The other thing about clean is that Maven 3, this is something that I didn't know, does have an incremental build feature baked into. And it's the job of the plugins to get into that particular feature. So the core gives you the basic capabilities. And if the plugin is implemented in such a way that takes advantage of the incremental build, then it's going to work. Right. But if we do clean, then those computer results, those artifacts, those test results, everything goes away. And if you do another invocation of a build, if you do Verify, you package, you compile, then you have to recompute all those things. So using clean defeats incremental builds. This is something that Robert, again, discusses on another session at DevOps, where he advocates for not using clean and for not using install. There is, of course, like in everything else, it all depends. Should I always avoid clean? Should I always avoid install? No. There are times where you must do clean, and there are times where you definitely want to do install, because what you want is to copy the artifacts from your local build into your local repository. But most times, you should be fine by just invoking Maven Verify. If for some reason a plugin does not work pretty well with the incremental builds, then we encourage you to open a ticket and say, hey, this plugin with this condition is not working. Can you help me fix it? And that's pretty much it, I guess. Here's another feature that I didn't know Maven had. So Maven is designed to invoke your build from the root when you have a multi-project build, because it has to construct the React. But you can invoke a subset of the Reactor by using these flags, PL, which stands for project list, and AM, which stands for also make. The one thing that I like about Gradle is that if you are in a multi-project build and you go into a module and say, I want to build this module, the Gradle computes the graph of all dependencies, including the sibling projects, and gives you exactly what you need. And you only need to say, I want to compile this module, and boom, everything gets compiled and gets built, and it works. I wanted something like this in Maven, and it so happens that the combination of these two flags, PL and AM, give me exactly that, or very close to it. So when you build multi-project builds inside a reactor, every goal is invoked for each one of those projects in that order. Say you have 4 projects. I'm going to show that actually in just a moment. Then the goal is going to be invoked first for the first project, then for the second project, the third, and the fourth, in that order. So when I say PL, Maven PL, what I want to say is that I just want to build that particular project. And if that project has no additional dependencies, then that's going to work. But if that project has additional dependencies, such a parent or depends on a sibling, then just using PL is not going to cut it. We have to pass in also -am, which means also make the dependencies that this project has. There's another flag called AMD, called also make dependence. That means that it will build this project and every other project in my build that depends on this project, so that way I can say that I'm not breaking those consumers down the line within my same project, if that makes sense. So let me show you what I mean by this. Now let's go here. Let's go one level up. And let's go into partial 1, I believe that is. Okay. Let's do a clean here, to be sure that there is nothing strange. So we have a parent POM and 4 projects. And if I look at the sources, the parent POM has, well, of course, its POM file, and each project has its own POM file, and each one of them has some sort of Java code. And one of them happens to be apparently a runnable class. Okay, so let's look at the parent. App coordinates, packaging POM, very important. And we use the modules section now. And we list the names of the projects. Well, actually, these are not names. These are file paths. But because it's very common for developers to put the projects adjacent to the parent, then the name of the project matches the name or the path that we see here. But if I really wanted to, I can go very crazy, very deep into my hierarchy, and then you will see quickly that these things are not just names, they're actually file paths. If I inspect project 1, and it's a simple POM with gap coordinates, nothing special. If I inspect project 2, I believe it has a dependency on project 1. Okay. Project 3, which remember, this is supposed to be an executable class. It's an executable project. It only depends on project 2. Okay, so we have now 2 dependencies. And project 4 has, like project 1, no dependencies. Okay, so of course, if I just do, let's do a compile here. The reactor at the top says, I'm going to run the projects in this order, the root and 4 projects. And the result of the reactor says, I took so much time doing what you asked me to do. Okay, not so bad. Let's say I just want to build project 2. For this to work, I'm going to clean so that nothing is there. And what is the group ID? I think is called Acme. So let's make sure that there is nothing installed. So I'm going to delete from repository, my local repository, anything that is called Acme. There we go. Oh. RF, I suppose. Yeah, force it. Okay. There's nothing installed Maven local. There's no way, there is no additional dependencies. Notice what happens when I attempt to resolve just project 2 like this. Doing a compile here. And I get a failure. Why? Because project 2 depends on project 1, and project 1 depends on the parent. So this is going to be a problem. There is no jar built for this. So, okay. So same command as before, but the notice that what I'm going to do is now add this AM flag. Also make. Now I got a reactor. And the reactor contains the parent, the dependency, and the project that I'm interested in. And now I get a successful build. That's pretty cool, isn't it? Okay. Remember I say project 3 has an executable class, com acme main. Looks like this. So what if I wanted to build this and run it? And we know that we can inject the Maven plugin, exec Maven plugin, just directly in the command line, right? So this will be akin of saying -am -pl. Let's build project 3. We're going to compile it, and we're going to execute that project. We need to pass an exec main class parameter because, well, we can. And the main class has to be com acme main. All right? See what happens. I got the reactor correctly. Yes, that's the number of projects that I want. But I have a problem here. What's going on? It says that it cannot find the com acme main class. Yeah, but it did not find it where? It did not find it on the root project. What is going on here? I thought it was supposed to work. Well, that's the catch. Every goal that we invoke in the reactor is invoked on every single project. That means that I invoke compile on the root, and because it is a type-on, it doesn't do anything. But the exec Java plugin was also invoked on the root, and it was going to invoke in project 1, project 2, and project 3. Now, of course, the first 3 projects have nothing to do with execution. They don't have a main class. That's what I get a failure. Is there a way that I can make this work? Right now, there's kind of like a workaround. And the workaround is making sure that you define all the plugins that you want to execute in, say, the parent using the plugin management block. And then just disable them. Sometimes you may need to define dummy values for some of those plugin arguments because otherwise the plugin will fail. And I can show you that right now. I have another version of this project. No, this is actually partial. That's the wrong one. Come on, partial 2. I can do a clean again. Show that it's kind of the same setup. Like the same organization as before, but notice what is different now at the root. The root has 2 properties that I just defined, so I don't need to put it on the command line. So one is to skip the execution of the exec plugin, and the other is a dummy value for the main class. It could be anything you want to as long as it's not empty. And in the plugin management block, I say, if you happen to need the exec Maven plugin, you should use version 1.6. Good. And then I also apply it. Notice that I just need to apply the group ID and the active ID, and everything else that I may have defined before in terms of this configuration is going to be reused here. Now, there's nothing else that I need to define because I set those as properties. That's one of the advantages. Now, project 1, if I can type it correctly, doesn't have any changes. Project 2, it's exactly the same. Project 4, it's exactly the same. Project 3, the one that is executable, is the one that changes. And what we're doing here is that we are setting a right name for the main class that this project has in the properties. And we also redefine the exec Maven plugin, and we set the skip property to false. I mean, I think we might be able to do it in the properties here, but here's another way. This is the long-winded way of you to redefine properties. Okay, so let's execute the command that we saw before. So that will be this one. Maven -im-pl, just project 3, compile and execute. We no longer need to do exec main class because it's already found in the POM file. Let's do that. And it now works. We got the reactor is the right subset, so project 4 is not here because it's not a dependency. In the first project, there's project 1, the exec plugin was skipped. For project 2, the exec plugin again was skipped. And for project 3, the exec plugin was invoked. This is what we want. So it's a little bit of verbosity to make this happen, but you can make it happen. Okay. Here's another interesting bit, which we kind of saw already. Aggregating pumps. An aggregating pump, it's a pump that has a module section. That's it. It could have more if you want to, but at the very least, it has to have the module section. It is very typical to find that parent pumps have modules, just like I showed in the previous example. But it is not a hard requirement for every parent to be an aggregator. It's also the inverse is conversely true. Not every aggregator has to be a parent pump. And this is a quite interesting bit that I didn't know. So you can split these two responsibilities. Remember that every entry in the module section is a path, is a file path, not just the name, okay? So why do we make this distinction about aggregating pumps? And why is it important to know that every aggregating pump does not have to be a parent pump? Here's the scenario that I have for you. You have your project, single project or multi-project, doesn't matter. And it depends on some project, excuse me, that has a bug. These are external projects. Let's say Commons Lang. Okay. And what you want to do is you want to fix your project. And so you check out Commons Lang and put it in some path, then fix the bug or try to fix the bug, push a release to Maven local or to your local artifact repository, and then go back to your build and test it. Oh, it's not yet fixed, doesn't work. So you go back to the other, try to fix it, push it again, go back here. Does it work? Yes or no? So you keep doing this loop until it works. Well, it just happened that pushing artifacts, you might forget sometimes to do it, and you may be consuming outdated dependencies, outdated versions in your project. Is there a way that we can close the feedback loop to make it shorter, to make it faster? Yes. If we were to have your project and the other dependency as part of the same multi-project build, then you can build both of them at the same time. That will make it faster. So how to make this happen? We make an aggregator pump at the top that says, I want to build these two. Now, these two projects, your project and the Commons Lang, do not have to share the parent. That's the beauty of this. They don't need to be modified in any case, only the version numbers, just by having the aggregator on top. So say we have this structure like this. I mean, you have a base pump or a bump pump. I think I probably have made a different demo for this that make it much more compelling. Let's go into the terminal, and now I go into aggregator. Let's do a clean to show that there's nothing strange here. It looks like this. There's my version of Commons Lang, of course, it's a fake one, my project. And my project has nothing, and Commons Lang has some sort of source code that I want to fix. So if I were to look into Commons Lang, spawn file is just gap coordinates. I chose a very large version of version so that it doesn't clash with anything out there, because group ID and actified ID are actually those that you may find in Maven local or Maven central. And my project looks like this. It's gap coordinates and has a dependency on version 99, which is my version of Commons Lang that supposedly will contain the fix. And the aggregating pump is this one. It's just gap coordinates with dummy values for group ID, because we don't care about those. We are not going to publish this. It's just for building. And notice the modules are the names of Commons Lang on my project. So if we were to look again into Commons Lang pump, there is no parent definition. If we look back again into my project, there is no parent definition whatsoever. But if I build my project here, here we go. The reactor says Commons Lang, my project, and aggregator. And it builds. If I were to make a change to Commons Lang, that will be consumable for my project. So we're almost done. And I have, I think, one more feature to show you, which is BOM files. Now, BOM stands for Bill of Materials. A BOM file is just like any other regular BOM, and it contains a dependency management block. You can have as many other elements as you want, but the most important element that you can define in a BOM file is a dependency management block. Now, the idea behind a BOM is that you put all the dependencies that make sense to come into some sort of group. There is no strict distinction coming from the Maven project, but I would say there are two flavors or two kinds of BOM files. What is known as a lib BOM and what is known as a stack BOM. A lib BOM is a BOM that defines all the modules for your project and nothing more. Say my project, in the case of the previous project that has project 1 to 4, if I were to have a BOM, then it will list dependencies project 1, 2, 3, and 4, and nothing extra. Whereas if I were to define a stack BOM may have as many of my projects in my multi-project build, plus third-party dependencies such as Guava or Commons-Lang, Commons.io. If you were to look into the common web frameworks and microservices frameworks like Spring Boot and Micronaut and Helidon, they do offer, and Quarkus as well, they offer two BOMs. There is the Spring Boot BOM or Micronaut BOM that defines the dependencies for that project only. And there is another BOM, usually with the prefix as, the suffix as dependencies, that includes the BOM, the lib, plus any other dependencies that I may need, like Jackson and Guava and Commons and whatever it is, right? So as a consumer, what do I need to do in order to take advantage of a BOM? Well, this is what I do. You define a dependency management block. You pass in the coordinates for that BOM file. And you have to have two additional elements that are very, very important. The first one is the scope. There are 6 scopes in Maven, and this is the 6th one, import. If you do not import the BOM, then things are not going to work. And the second one is that the type of the dependency has to be POM. If we were to omit this, then Maven will think the dependency is of type jar, which is the default type. And that's not the case. Every BOM file is actually of type POM. So when we do this, what's going to happen is Maven will resolve this dependency and read the dependency management block that it has and copy over into my BOM file. So it's like just assembling different dependency management blocks on my own. So now that I have that, and we know now that everything that is bound or found in my dependency management block can supply dependencies, can supply versions. So given this, I can define in this particular BOM file, I have a dependency to Guava, so I can just define the group ID and the artifact ID, and the version will be provided by the BOM. And every other dependency that is brought by the BOM can be consumed in this way, whether it is a direct dependency or a transitive dependency. I think we're pretty much done. I'm not going to do a demo of this one, because if you are using Spring Boot, Micronaut, Helidon, Quarkus, or any of those big frameworks, then you have probably seen BOM files already. So this is pretty much it. I know there are a few other features that I didn't mention, and this is just the tip of the iceberg. I used to think that Maven was just a dumb tool that used XML as a DSL. There is actually a lot of work going into under the covers. There are interesting features out there, and it can be a match to a Gradle in many areas. Now, there is no option for me to say you should use always one or you should use the other two over the other. It depends on your particular setting. Is your team more inclined to use Maven because they have long history of using, or there's a specific plugin that exists in that area that does not exist in the other, or is the speed of releases within one build tool and the other that makes sense for you? You have to make an evaluation. I have a few resources if you are interested to know more about the basics and getting into further into Maven. So there is a series of blog posts that I have started writing from last year. It's called the Mastering Maven series. It's an ongoing series where I go from the very basics, and now we are starting to cover the medium advanced topics. There is another blog series by a friend and fellow Java champion, Chandra Guntur, called The Understanding Apache Maven, where he goes more into other details that I didn't cover, such as profiles and the life cycle and the goals. And if you happen to be using Gradle, like I do, and you are missing some of the features that we showcase today and some of the features coming from Maven, like I do, there is a set of Gradle plugins that give you those missing Maven features on top of Gradle. Because you can have a Maven-like structure on top of Gradle just because of conventions. That is known as the Cordon Gradle plugin suite. So with this, I think that that's everything that I have now. I only have a couple of minutes for any questions that you may have. I hope that you found the session interesting and that will give you an idea of what to look for, what to look after into Maven.
Thank you very much for your great talk. Probably we have a time for one or two questions. Speaking about dependencies, you said that Maven doesn't look at version, it just uses its own algorithm when traverses the tree, but probably it's still possible to force Maven to use all the latest versions in case of conflicting dependencies.
Yes, it is possible. One way to do it is, well, you have to be aware of which versions is if you use the dependency management block. The other way to do it is apply the enforcer plugin, and there are a handful of rules that can help you. One of them is called require upper bounds. In this way, if you have two different versions of the same dependency, the build is going to fail. They say you have version 2 and version 1, the build will fail telling you these are different. And you should pick the version 2. There is another rule called Dependency Conversion. Again, when it detects there are different versions of the same dependencies, it will fail immediately the build, and it will tell you in the graph which dependencies in a transitive way are bringing those that are giving you trouble. There are ways for you to ban dependencies given certain patterns if you want to, so that way you don't have to change the POM file explicitly, you just apply a single rule. And I believe there are other couple of rules that show this.
I see. Thank you.
Yeah.
Thank you for your answer. And if you have more questions, you can ask them in discussion area. And we will be here for the next talk in 30 minutes. So see you later at Snow One.
Thank you very much. See you, everybody.